Let's begin with a simple inquiry. In a universe that is defined by constant motion, from the silent crawl of a spider to the grand orbit of the planets, what exactly is movement? And what can observing it teach us about the very nature of reality?
It might seem like an unusual question, I know. But the answer? Well, it hints at a really profound simplicity. Think about a flock of pigeons scattering in an instant, a flurry of wings moving in perfect, uncolliding harmony. The universe itself, in all its mind-bending complexity, seems to operate on a similar principle of effortless, unwritten rules. Let's dive into this. And this presents a kind of puzzle. We humans, we consider ourselves the most intelligent species, but we need years of training and complex rules just to navigate traffic without chaos. Yet the rest of the universe, ants, birds, fish, even entire galaxies, moves in a state of what looks like innate harmony. So what accounts for this difference? This slide really shows that stark contrast. On one side, you have the chaos of a human stampede, where panic just completely overrides coordination. And on the other, you see the effortless harmony of a school of fish, where hundreds of beings move as one. One is governed by confusion, the other by some simple, unspoken law. To understand this unspoken law, we first have to deconstruct the very act of seeing. To really know what movement is, we have to identify the essential components of how we observe it in the first place. Okay, consider this simple scenario from our source text. A vase is just sitting on a table. It's not moving. So here, we have two entities, the vase and the table. And over a period of time, there's no change in the vase's position relative to the table. Simple enough. Now, a spider crawls on that same vase. We again have two entities, the spider and the vase. But this time, over a period of time, the spider's position changes. This simple picture brilliantly illustrates the basic components we're looking for. So, from that very simple observation, we can actually distill 4 necessary conditions for any movement to be perceived. You have to have an entity that moves, a frame of reference against which it moves, a change in space or position, and, crucially, a change in time. Without all 4 of those, no movement can really be said to exist for an observer. Now, that second condition, the frame of reference, that's the key. It's not just some passive background. For the purpose of observing a movement, the frame of reference is the point of observation. It's the stable ground from which we measure change. In a very real sense, it is the observer. And this inquiry leads us to a crucial rule. The frame of reference and the observer are one and the same. Whether it's a vase, the earth, or your own body, the entity against which movement is measured becomes the point of view. It becomes the observer for that specific event. This leads to a pretty critical question, though. We've established that the frame of reference is the observer, but why does it have to be non-moving? I mean, after all, we observe things while we ourselves are in motion all the time, in a car, on a rotating planet. The answer lies in a simple practical experiment. To demonstrate this, let's just consider a simple experiment. Imagine a piece of paper with 2 holes, and each one represents a point in space. The goal here is to create a relative movement between them by tearing the paper from both holes at the exact same time. So we apply an equal force, pulling outwards from both holes. We're intending for both of them to move relative to each other and tear. The intention is to create 2 simultaneous movements. But just look at the result. It doesn't matter how many times you try this, only one side ever tears. The other hole, which is the stronger point, remains intact. It automatically becomes the non-moving frame of reference against which the tear, the movement, is observed. You see, you can't have 2 relative movements at once. One must become stationary for the other to even be perceived. This experiment establishes our 4th rule. The frame of reference, or the observer, is conceptually non-moving. Even on a train that's moving at 100 kilometers per hour, your observation of a dropping ball happens within the train's frame of reference, a system where you are stationary. All observation requires a fixed point. Now, let's expand this principle. What if this mechanism of observing physical movement, of measuring change against a fixed reference point, is actually the basis for all the knowledge we get through our senses? This diagram here really models the whole process of perception. You have a movement being compared against a reference within the fabric of space and time. The result of that comparison is attention, the act of observation itself. In essence, every single perception is an act of comparison. Think about it. We only know hot in relation to our own skin temperature. We only perceive something as big in comparison to something smaller.
Even history is just a narrative of events recorded from a particular fixed point of reference. All of our sensory knowledge is really just a measurement of difference, of change, relative to the observer. And this leads to a pretty profound consequence. If observation is the detection of difference, then the observer can never perceive a state that is identical to its own. An eye can't see itself. Your skin can't feel the temperature of an object that is exactly 37 degrees Celsius. It just registers as nothing. The observer is, in a way, blind to itself. This reveals a fundamental law of perception. Our senses are not designed to register constant states. They are designed to detect change. You only feel your glasses on your nose the moment you put them on. Once that sensation becomes constant, it just fades from your awareness. We are literally wired to notice movement.
So, if our senses can only perceive change and movement, where does that leave our search for truth? If we define truth as something permanent and unchanging, how could we ever hope to find it with senses that are built only for the temporary? While in a survey from our source material, people were asked the color of a blue cap. For the true answer, every single person said blue. The truth was singular and constant. But for the false answer, they gave dozens of different colors. Falseness was multiple and ever-changing. This gives us a working definition. Truth is singular, permanent, and constant. Falseness is multiple, temporary, and always in a state of flux. This brings us to a rather stark, logical conclusion. We've established that our senses only notice change or movement. We have also defined truth as something that is unchanging and permanent. Therefore, truth itself cannot be directly perceived by our senses. It must exist outside the realm of what we can see or hear or touch. So how do we find it? This final metaphor provides the answer. Participants in the study weren't asked to find the apple. They were asked to color everything that was not an apple. By systematically identifying and filling in everything that is false, the one thing that is true, the apple, is revealed in the empty space that remains. We don't find truth by looking for it, but by clearing away everything that is false. And this leaves us with a final question. Our lives, our thoughts, our entire world is a sea of constant change. If we find truth by this method of elimination, by disregarding everything that moves, what then is left behind? What in our world is truly permanent?